Visual Chirality by Zhiqiu Lin, Jin Sun, Abe Davis, and Noah Snavely. The visual world is complex and varied, which is part of what makes problems in computer vision so difficult. And a major lesson over the last decade has been that you can never have too much data. Even simple tasks like training a network to detect cats essentially amount to using some limited set of examples to estimate a distribution over all possible images. So it's not surprising that we need a lot of data. One common way to help get that data is to augment training sets with mirrored versions of each training image. The idea is that if we combine 1,000 cat images with 1,000 reflected cat images, we get 2,000 cat images. But here's the thing. The world we see through mirrors is different from our own. Text reads backwards, right hands become left hands, and clockwise motion becomes counterclockwise. To quote Lewis Carroll, it's just the same, only things go the other way. Now we have a pretty good sense of how this works geometrically, but despite widespread use when training deep networks, we know a lot less about how it affects what we learn from visual data. So that's what this paper is about. How does reflection change what we learn from image data, and how should this inform the way that we think about symmetry in visual distributions? We use theoretical analysis and learning experiments to analyze symmetry in both distributions of visual content and in algorithms which process that content. Then building on this analysis, we show how to discover and visualize reflectional asymmetries in distributions of real-world data. So what is visual chirality? Well, in geometry, a chiral object is one that lacks reflectional symmetry, and therefore can't be aligned with its own reflection. This is what makes a right hand different from a left hand. But in the wild, there are about as many left hands as there are right hands, so when it comes to learning, augmenting one with the other isn't necessarily a problem. But what if we consider images of hands giving a thumbs up? Most people are right-handed, so you're much more likely to encounter a right hand making this sign than a left hand. This asymmetry of visual distributions is what we call visual chirality, and it indicates when augmenting with reflection will introduce bias into machine learning. Building on our analysis of both distributions and image processing algorithms, we show how deep networks can be used to identify, group, and visualize different sources of visual chirality in a self-supervised way. For more information, see our paper and project website. Thank you.